All right, so we are starting the rest of chapter 6. We've got 6.5, 6.6, 6.7, and 6.8 to do. 6.5 and 6.8 on their own are pretty short, so I just put them together. 6.8 is just the graphing part, and once you see one of those, you'll say, oh, I can do this. I know how to move graphs around. So that shouldn't be a big deal. So we're going to do this lesson today. On Wednesday will be 6.6. When we come back from spring break, we'll do 6.7, a review, and then our test. So 5 days total for this unit. Your test will be on April 2nd, a Friday, since our virtual Fridays are out the window. But all work from this unit has to be completed by April 2nd. It will close in CUDA on that date. Okay? All right, so when we are solving equations that have square roots in them, we have a couple steps to do. So this is for our square root equations, or any kind of root equations, actually. It could be a cubed root as well. The first thing that you want to do is you want to get the root by itself. And if it's a square root, you're going to square both sides. And then we will solve. If it's a cube, you'd cube it. That says raise, not tase, both sides. We're not tasing anybody in here. Raise. I think after what we've done recently, you'll say, oh, this is easy. Hopefully so. So we want to get the root part by itself by moving everything else to the other side. Then we'll square both sides and then solve if we haven't any other extra steps. Okay. So on number 1, what is outside of the root? What number is outside of the root? The 9. So we had a plus 9. So to get rid of that, we're going to subtract 9 on both sides. So we have 4 is equal to the square root of p. And at this point, you can probably just tell me what p needs to be. The square root of what equals 4? The square root of... Anybody want to mouth it? 16? Yeah, I saw a 16. The square root of 16 is equal to 4. But a way for us to do that, we're going to square both sides. We're going to raise both sides to the second power. And 16 is equal to p. Because remember, if you square a square root, the square root sign goes away. You're just left with what's on the inside. And we can always go back and check it. The square root of 16 is 4, plus 9 is 13. All right, on number 2, what is next to the square root that we need to get rid of? The 7, and it's 7 times. So to get rid of the times, we're going to divide by 7. And 21 divided by 7 is 3. And y'all can probably tell me this. The square root of what is 3? 9. But we'll make sure we'll square both sides. And 3 squared is 9 is equal to k. Occasionally, you do have to do one more step after you've squared both sides. We'll see that happening on numbers 3 and 4. Number 3, we have a 3 in the front. How are we going to get rid of this 3? What operation? It's 3 times. What's the opposite of times? Divide. So we're going to divide by 3 on both sides. So the square root of v plus 5 is equal to 5. When we square both sides, we don't change anything that's inside of the square root sign. That's all going to stay with us. So when I square that, all it does is take the square root sign away. You're still left with v plus 5. I don't change that part at all. What's 5 squared? 25. And what plus 5 is 25? 20. Yep, so v is 20. All right, what's happening on the other one? What needs to get rid of? What do we need to get rid of on number 4? The 2, that's outside the root sign. So we want to get rid of the things that are outside of the root sign. Was minus 2. What's the opposite of minus 2? Less. So the square root of 25 minus 1 is equal to 7. Is the square root by itself? There's nothing else around it, so that's good. So now we're ready to square both sides. We don't change anything inside of here. The root just goes away. And 7 squared is 49. All right, can y'all do this one in your head? I bet so. Once you do that one in your head, raise up your number of fingers for your answer. Yep, a couple people got it. You can write it down too if you need to. Yeah, So we'll solve this two-step equation. Anybody else want to show me your answer? We add 1 to both sides. 25n is equal to 50. I bet y'all can get it now. Divide by 25, and n equals 2. All right. And our very last one, I just wanted to have one that had a dividing in it just so you'd remember what to do. On number 5, how do you get rid of this minus 5 at the outside? What are we going to do? What operation? Good. So plus 5. Negative 4 plus 5 is 1. Since the square root is by itself, now we will square both sides. One equals r over 6. And we have divided by 6. What's the opposite of divide by 6? What operation? Times. You're going to multiply by 6 on both sides. 1 times 6 is 6. So r equals 6. So I multiplied the 6 over to the 1. How are we feeling about this first type of problem? Get the stuff away from the square root, square both sides and solve. Thumbs up for that. Middle thumbs, y'all okay? Okay. All right, so the next type of problem we're going to look at, they have fraction exponents, and we want to get rid of that, or our rational exponents is another way to say it. So to get rid of problems that have rational exponents, we're going to get the base and power by itself, similarly to getting the root by itself. And then we're going to raise to the reciprocal power. Do you remember what reciprocal means? Reciprocal means you flip it over. So we're going to flip the power over, and I'll show you why that helps us out here. So to solve these with the fraction exponent, you want to get the base and power by itself. So we get the base and power by itself, raise both sides to the reciprocal power, and then we're going to solve. All right, on number 6, our base and our power are by itself. We don't have anything else like in the front of it or added like we do on number 7. So step 1 is already done for us. So we're going to raise both sides to the reciprocal power. So we started with 3/4. So when I flip 3/4 over, I'm going to get to the 4/3. Okay? We raise both sides to the 4/3. Because 3/4 times 4/3 is 12/12, right? 12 over 12. What is 12 over 12 the same as? 12 over 12 is 1, and then we don't have that exponent anymore. We're just left with the n. So when we raise to the reciprocal power, it's always going to make our power a 1, and we're just left with the n. And you guys can put your fraction exponent in the calculator if you want, or if you want to evaluate it yourself, you can. But this is 16. Remember, we do the cubed root. If we wrote it out, the cubed root of 8, and then that would be to the 4th power. If you wanted to do it by hand, that's fine. Like this. Just a reminder, this is the cubed root of 8 to the 4th power. The cubed root of 8 is 2, 16. But I don't care if you put that in the calculator. Number 7, is it ready for a reciprocal power yet? Is the base and the power by itself? No, not yet. We have 2 things we're going to have to move on this one. The first thing we'll move is our 3. How we're going to get rid of this minus 3, what operation? So we'll add 3 to both sides. So we have negative 2,916 equals negative 4k to the 3/2. Is the base and the power, or are the base and power by themselves yet? Nope. What is our base? Our base is just k, and we have that negative 4 in the front. So we have to divide both sides by negative 4. So here we go. And that is 729. So if 729 is k to the 3/2, what are we going to raise both sides to get rid of that 3/2 power? What's going to go on the top of our fraction? A 2? A 2, and what's going to go on the bottom? A 3, right. We're doing 2/3 power on both sides. That is the reciprocal of 3/2. And I don't want to try to figure out 729 to the 2/3 in my head, so I'm just going to put it in the calculator. Because sometimes I get lazy. It's 81. Cool. So remember, we raise it to the reciprocal power, so this becomes k to the 1st, because we'll have 6 over 6, which makes it 1. Any questions on these time where we're raising it to a power, to reciprocal, we flip it over? Okay. All right, we'll try one more. This base is 4a. Because it's in parentheses, we can't do anything with that 4 right now. So right now is when we're going to go ahead and raise it to what power? It's the same power as the last one, right? We're doing 2/3. So those will cancel. We'll have 4a is 216 to the 2/3. Yeah, I think it's 36, yeah. And then y'all know what to do from here. What are you going to do next? Divide by 4, and our answer is 9. Any equation questions? Okay. When you are working these problems out, I think I forgot to put a star next to the kind with the exponents, but any equation problem you need to work all the way out. I just forgot to add that on your assignment. You don't have to work the graph ones out on paper, but you do need to do all your equations. So now we'll work on our graphs. We're going to graph square and cubed roots. This will be fun. We're going to make a table for square root and cubed root and sketch them both. Then we're just going to move them around the page. So normally when we're doing graphs, we do -1 or -2, -1, 0, 1, 2 for our x's. Here's going to be different. We want to pick numbers that are actual square roots. So what's a perfect square? Somebody give me a perfect square.
4.
4, good. 1, right? What about 0? We'll start with those. 0, 1, and 4. Those are going to be our x values that we'll use when we sketch our graph. What is the square root of 0? If I plug in 0, square root of 0 is 0. Square root of 1 is 1. What's the square root of 4? 2. So we're going to plot these points. Can I put a negative in the square root and get a number that I would graph? No, it would have an I in it, and it's not going to be on our regular X and Y plane. So our graphs are going to start at the 0, 0 point, and then they're going to go from there. But they're not going to be like to the right of that, and they're not going to be underneath it because that's our starting point. We got 0, 0. Yes.
You made this one up, or it go with number 9?
I mean, this is how you do the basic one. Number 9, we're going to move this one around.
Okay.
Mm-hmm. And then 1, 1, and then 4, 2. So our square root graph looks like that. It's basically half of a parabola turned on the side. Like if I did a replica of this on this side, it would be like a U shape, but sideways. So this is our square root graph. We have our starting point. Then we go up 1 over 1. Then back from our starting point up 2 over 4. So it's just the reverse of our quadratic where we did 1, 1, and then 2, 4 this way. Now it's 1, 1, 2, 4. So when we're asked for a square root graph, you're going to graph this. We're just going to shift around where our starting point is. So if it's inside, it goes left and right, outside, up and down, just like before. But same pattern, over 1, up 1, over 4, up 2, or up 2, over 4, whichever way you want to say it. Okay. Do you want to go ahead? We can go ahead and graph all the square root ones, and we'll do our cubed root. That sound good? So we don't get confused there? Okay. All right, remember, if numbers are on the outside, that's moving it either up or down. So which way is this graph going to be shifted? Down 5 units. Okay, so we're just going to do this square root graph. It's going to be down 5. So we start at -5, up 1 over 1, up 2 over 4. And we just draw that little thing. We'll do number 10, and then we'll go back and write the domain and the range for these. All right, so inside our operation, that's either left or right. Remember, if it's a minus sign, which way is it going, left or right? It's going to the right. Remember, the minus or those are going to be opposite if you're doing a left and a right. So this means right 1. Start at 1. I went right 1. And then I do my pattern. Up 1 over 1. Go back to the beginning. Up 2 over 4.
Why wouldn't it be the same as 9?
The same pattern?
Yeah, it's the same thing.
We did. This has the line all the way across the 1. This one stopped here. The 5 was on the outside. This one's on the inside. Mm-hmm. Yeah, outside's up or down, inside's left and right. Okay. Now we're going to write our domain and range. Do you remember what domain stands for? Is that the X or the Y? Domain is X and the range is the Y value, right? So we're going to say, we'll do this one first, then we'll write these two. The domain, we're going to go across and see where our X values begin. So on our basic graph, our X values begin at 0 and then they increase, right? I've got 0 and everything bigger than that. So for our domain, X is greater than or equal to 0. We start at 0 and we keep moving that way. And for our range, what's the first Y value we see? Our Y value is also 0 and then it gets higher. Then we have a 1, then we have a 2, then we would have a 3. So for this one, our Y value is greater than or equal to 0. So that's on our basic one. When we shift it, it's going to change. The X and the Y could change or they could both change. So we'll see what these are. So on number 9, what's our very first X value? So we're going across the X axis. What's our first X value? Where our graph exists. Did we shift left or right at all on number 9? Did our graph move left or right? No, it just went down. So we didn't shift it at all. So our beginning X value is 0. So this is 0. X is greater than 0. And what is our lowest Y value? -5. And then we go up from there. So Y is greater than or equal to -5. So from this point, we're going more than in the X direction and more than in the Y direction from this ordered pair, which was 0, -5. This X comes from there, the Y comes from there, the ordered pair from that starting point. What is going to be the X value for our domain? What's our starting X value? If I go across, where's the first part that I see? It's going to be 1, greater than 1. And our range, what's the lowest Y value? 0. Y is greater than or equal to 0. And remember, this ordered pair was 1, 0. So the X for the domain comes from that ordered pair, and the y is for the range. All right, 2 more square root graphs, and then I'll show you the cubed root, and you'll have a good amount of time to work. I'll get that written down. All right, on number 11, I've got a double. We got this little a 2 movement here. I have a +3 on the inside. Is that a left or right or an up or down? An inside number. Inside numbers are left and right for inside numbers. So this means I'm going to the left 3. And outside numbers are up and down. So it means I'm going to do what? Down 4. So left 3, down 4. Do our same pattern. Up 1 over 1, up 2 over 4. What is our starting x value? Our graph starts at -3 for the x. And our starting y value is -4. Oh, I wrote a y for the x. Silly me. This ordered pair was -3, -4. -3, -4. We see a connection between the graph and the domain and range, where those numbers come from. Okay. All right. The only difference between 11 and 12 is we've got a negative in the front. Remember, a negative in the front of a function. What's a negative in the very front do? Like if I had a negative in front of a parabola, it just flipped it over. So same thing, square root graph, it's going to be flipped over. So instead of going up and over, we're going to go down and over because of this negative. This is going to give us a flip. And we're going left 1 because it was a plus sign, and we're going down 1. Left 1, down 1. And it flips over. So instead of up and over, we're going down and over. What number is going to go with our domain? Which x value are we talking about? -1. So our x's are more than -1. And since we flipped over for our range, we're not going to say greater than because our numbers aren't above this. Our numbers are less than -1 now because our graph is going down. So y is less than or equal to -1. So the only time your range will switch less than or greater than is if your graph is upside down. All right, and we will look at, I will sketch the cubed root for you so you can see that. We'll pick some perfect cubes, -8, -1, 0, 1, and 8. So those are perfect cubes. They would be perfect in there. -2, -1, 0, 1, and 2. Just doing this quickly so you can just see it real quick, and then this is easier to move around, I think, than the other one is. and we plot them. And it looks like this weird little curve thing. It goes like this and then curves up like that. So the transformations of the graph are the same. If the numbers are on the outside, it's moving this shape up and down. If the numbers are on the inside, it's going left and right, and it's opposite of what you would normally think. And do you want me to do one transformation of this kind? Then y'all are good? Okay. I'll let you finish writing that down. Okay, I'll go back up to it if you need in a second. Oh, I did give you some on your homework where it didn't ask you to graph it, like it didn't give you the graph. It just wants you to graph it yourself and then say the domain and range. So just do a little sketch by yourself, like, oh, this one goes this way too, so I'm going to do my own sketch and then write the domain and range. Okay. Okay, our cubed roots, this would go up 1. So I go up 1, and then I put my points. So my center is what gets moved. And I just follow the pattern, and this pattern is just a little bit different. It's over 1 up 1, over 8 up 2. But as long as you can see that the center is moving, the center point here would go up 1, and you would be able to identify your graph. Which way are we moving on 16? A plus 4, yeah, we're going to the left 4. Left 4, that's our center. Then we do our points here and go over 8 up 2. I'm not going to make you draw any of these by hand, so it's okay. Just be able to identify that this one went 4 over. So you're just getting that very center point to move about. Do you guys remember all of our transformations we did a while ago? Those coming back to you now a little bit. Up and downs at the end, insides left and right, a negative flips it. Okay. If you're okay with that, you should be fine with this section. All right, guys. Go ahead, get working on that. If you have questions, let me know. You don't have to draw any of the graphs on your own paper. You do have to write down the equations, though. Okay? But if you want to skip and do the graphs first, that's fine. And then the equations, that's good too. I set up the rubric a little different on Google Classroom when I'm grading it. So there will be a part for me to mark you did the CUDA and then a part for me to mark that you did the work. And if your work is copied from somewhere or you don't have any work or it's just the problem and then the answer with nothing in between, I'm not even going to send that back and say do it again. I'm just going to put a 0 on that part. Okay, this is the 4th 9 weeks. We know that we shouldn't be copying. We know that we should attach our work every single time.